Okay, thank you, Aaron. I am just good at planning like small events, like what 10 people or for my team or for my close friends. Organizing a conference at this scale is very tough, and I would like to like you to give big hands to all the organizers of CascadiaJS. Thank you very much. Okay, so before we start this talk, I need to take a selfie because if it didn't happen on social media, did it actually happen? Thank you so much. And this is a generic talk about, okay, let me just start. So this is a generic talk about publishing in JavaScript ecosystem, how to keep everyone happy. And I see that all of you got bingo cards, right? So my talk is going to contain lot of words, yeah, like stack, stream, benchmark, sorry, that would constitute as cheating. But let's start with the talk. So my talk is about publishing in the JavaScript ecosystem, how to keep everyone happy. My name is Trivikram Kamat. I am software development engineer with AWS SDK for JavaScript. And my Twitter handle is Trivikram, and my GitHub handle is Trivikar. Now, 80% of you would have forgotten my name by this point in time. And 20% of you will remember the stale joke which I used in the previous CascadiaJS conference. So let me use that again. So you know this beautiful trio of volcanic mountains west of Bend, these three sisters. Let's take 3 from there. And we are in United States where a certain style of yoga is popular called Bikram yoga. Let's take Vikram from there. So that's my name, Trivikram. Okay, it didn't land. That's fine. So let's do a reality check first. The reality check is you cannot make everybody happy, okay, in tech as well as in your life. But you can try your best. So let's try our best. So if you're active on social media, then hashtag CascadiaJS is the official hashtag. Since this talk is about publishing in JavaScript ecosystem, you can also use JavaScript, node.js, and npm. So why talk about publishing, right? Publishing seems to be a very simple step, right? No, it isn't, because there are so many browsers, Chrome, Firefox, Edge, Safari. Then there are servers, Node.js, Dino, Cloudflare Workers, Bun. Then there is JS native, React native, NativeScript, Flutter, Ionic. Then there is module formats, CJS, ESM, AMD, UMD. Then, oh my God, when is it going to end? Sizes, publish size, install size, bundle size. Then you have types, flow, TypeScript. Then you have debugging, sources, source map. Then there is observability, open telemetry, open tracing, and open census. If you want to take a picture to share on social media, this is the picture. I'll wait for 5 seconds. So my Twitter username is at the bottom of the slide, so you can tweet to me. I'm pretty active there. Yeah. And since this talk is in recorded format available on YouTube, you can just jump to whatever you are interested in. So let's see what we are going to cover. So we are going to cover which criteria affects your package, okay, because that is what matters, right? And evaluate why, how, and what of each criteria with some approximations based on data, okay. Note that these suggestions are based on assumption that you maintain a package on npm using package.json. We will mention Dino first packages in one slide if you want to give them a try. So which criteria will affect you? There is one answer, and that's the answer. It depends, okay? It depends on what and how of the problem solved by your package, and where and how do users want to use it. So every time you want to find the answer to any criteria, ask these questions. So let's see why, where, and how do users want to use your package. Okay, ask them, okay. And if your package is popular, they will tell you, they will find you, they will tell you, which is good. And you can also populate data in telemetry if your package supports telemetry. So let's see the publishing criteria, that is why, how and what of browser, server, native, module formats, size, types, debugging, tracing, and I have 20 minutes. So criteria, browser. Why do you have to support browser? Because JavaScript is the language used for scripting in the browsers. Some of you might have sighed saying that there is WebAssembly, which allows non-JS code to run on browsers. But don't worry much about WebAssembly. It's going to be used for special use cases. Yeah, I don't think it'll replace JavaScript. But so how do you support browsers? So in your npm package, you use the browser field, and then you tell where your browser code lies. It's straightforward. If a certain module is not there in browsers, let's say boolean false. If certain module exists on browser in certain file, give that file path, or for server you can use clients. So what do you need to support? Isn't JavaScript support fragmented in browsers? Answer is yes, but there is a big but. That is, Internet Explorer has retired on June 15, 2021. So you don't have to support ES5. And Safari is likely getting competitive. EO is forming some draft rule about iOS monopoly of WebKit, and they are hiring also. So don't worry about browser support, it's going to become better. So now criteria, server. Why do you have to support servers? Because Node.js server you have to support because you have JavaScript developers who can write server code, so it becomes easy. You don't have to hire developers who are proficient in other languages. So in servers, Node.js is the most popular JavaScript server runtime. Not just JavaScript server runtime, it is one of the most popular server runtimes. So support Node.js. Dino is being used in more products. Last I heard, Supabase, Netlify, and Slack also are planning to use Dino. So that might be important to you. Cloudflare Workers is going open source, finally, after 4 years. That is good news. And we have a new kid on the block, Bun, which is very viral right now because they have prioritized performance and NPM support. So let's see, is it bad that there are so many competing server runtimes? Because they have a competing browser implementation also, right? No. Why is that so? Because now there is web interoperable runtimes community group, which Dino, Node.js, and Cloudflare Workers are part of. So they are trying to standardize how a JS server runtime should work like. So there, it's a good news that there will be standards in JS server runtimes also. So let's see how of Node.js. Just add file path in the main entry of package.json. That's how you support Node.js. How do you support Dino? So Dino, good news is Dino 1.25 added experimental NPM support, and they are planning to prioritize it over the next 3 months. So hopefully your NPM module will just work as it is, and you don't have to make much changes. And if most of your users are on Dino, then you can publish your Dino module on NPM using DNT. So you can write a Dino module and then use DNT to publish to NPM. How do you support Cloudflare Workers? Any Node.js package that uses Webpack or another polyfill bundler runs in Cloudflare Workers, so you don't have to support that separately. How do you support Bun? Don't. Bun natively implements many Node.js and web APIs, and it's very new. Okay, so as of August 2022, it's pre-alpha. Their parent company is aiming stable release by Feb 2023. So look out for updates and then decide. And also, it supports most of the Node APIs, so it should work out of the box. So let's see what you need to do. Again, it depends. Support the server runtimes that users want. But since Node.js is more popular, your users will most likely need Node.js. Now let's talk about JS native. What is JS native? So you write in JS native frameworks, you write JavaScript code, but the UI framework creates native apps. So it's very beneficial. You don't have to employ Android developers and iOS developers separately, or Windows developers. Just write JavaScript code, it works mostly in most platforms. So progressive web apps have some limitations like lack of push notifications. That's how JS native frameworks are helpful. And JavaScript native performance trade-off have significantly reduced over last 5 years. So now your JS native applications won't be that terribly slow compared to native applications. So how to support Node.js? How to support JS native in your module? So React Native parses code from .native.js or TS files, so you can write your native specific code there if required. I could not find how it happens in native script, Flutter or Ionic, so you just have to read that documentation. So let's see what of JS native. It depends. Support the native frameworks your users want. React Native apparently is most popular right now, so most likely you have to support React Native. Now we come to module formats. Everybody is waiting for this. So modules are building blocks of software, and module format is a syntax used to define a module. When JavaScript was getting popular in early 2000s, there was no standard module format, and multiple module formats were developed and used in parallel. So just a warning, conversations may get heated when opinions are shared about module systems, so take suggestions with a grain of salt. So which are the module formats? ESM is ECMAScript standard format, module format is official standard format. CommonJS is original module format supported in Node.js. There was AMD asynchronous module definition specifically made for front end, and universal module definition specifically made to work universally. Those are not that popular right now. So how do you support module formats? If you're supporting a single module system, add that file part in the main entry. So this is where your code will lie. Okay. In case if you're using TypeScript like distributed file main.js, that's where the code lies. But if you're supporting both CommonJS and ESM, then you have to use export maps. So you have to say exports, and for import you have to tell where the ESM code lies, and for require you have to tell where the CJS code lies. Now how do you support CJS ESM? So you can also use ESM module wrapper. So that is, you write everything as CommonJS, that is exports.name value, and then you write a new file, index.mjs, which imports the CJS module and exports it as ESM module. I personally prefer the dual packaging, but it's up to you, whatever works for you. So you might mention you might have to write this code again, CJS code and MJS code duplicate code, but there is a module called Gen ESM wrapper, which Anna wrote, that allows you to create ESM wrappers for any CJS code which you want to export. So ideally, you should only support ESM. I thought somebody will throw a shoe. Okay, but this will break your users on Node.js whose application code is written in CommonJS format. So be a good citizen of JavaScript ecosystem and support both CJS and ESM if you have to support Node.js. So sizes, then we come to sizes. So what are the sizes, different sizes? Publish size is the size of the package which you publish on NPM or the registry. Install size is the size of the node modules folder when your package is added as a dependency. And bundle size is size of the file generated when a bundler is used on the application code for your package. Bundlers are usually used for the front end. So why do you have to worry about sizes? So if publish or install size is small, your install will be faster. So that's one advantage. Then your package will have smaller carbon footprint, which will become important in next decade. Adding your package will not exceed the size limits in resource constrained environments like serverless or IoT devices. And if bundle size is small, the load times of the final application will be faster, so your users will use your package if their size is small. So how do you reduce publish size? Write minimal code needed to just fix the problem. Okay, don't write some additional code which is not that useful. Use package.json's files entry to only publish required files, thus removing unnecessary files. You don't have to publish tsconfig.json, for example, if you are transpiling your JavaScript code. Consider moving TypeScript types to definitely typed. Okay, TypeScript users will not like this. because they want everything to work when you download the package. But then if you want to reduce the publish size, this is something you can consider. I'll tell you how it happens. If you're using TypeScript, you can publish sources and source maps in debug variant of the packages using this text. I'll come to this later. So that way, your default variant will not have sources and source maps. So how do you reduce install size? So have minimal install size is a size. Have minimal or no dependencies. Okay. Share tips on reducing the install size with the packages you depend on. So their install size will be smaller, and your package install size will be smaller. Provide a variant of your package just for resource constrained environments using a disk tag. So I'll show you how it works. So if you have a scope package name, that is the default variant of the package, that contains code for all platforms. Okay. And then you can create node variant of your package, which only contains node.js specific code. Let's say you only want to support CommonJS and not have ESM or not have types. That can reduce the install size. So how do you reduce bundle size? There are multiple tips here. Make your package tree shakeable. That is, bundlers will use the dead code elimination and reduce the code which is not being used by your users in the application. Use named export, so it becomes easy to just include the code which is required. Publish a ESM version of your package. There are multiple bundlers which are ESM only, and they are doing pretty good job. So yeah, provide a ESM version. And make your package side effects free. That would also help reducing the bundle size. And final thing is you can split your code into multiple smaller modules. That will have its own set of problems. But usually it is better to have modular packages which does just one single thing. So let's see the what of sizes. It depends. Okay, again, like you will come for this talk and like, oh, for every criteria, Trivikram just said it depends. So it's always good to have a small install publish bundle size, but still see like whether it's required for users, whether you should spend time on it. So let's see types. So JavaScript is dynamically typed language, and types are checked and errors are only spotted at runtime. When TypeScript was introduced, they did some research and found out that 15% to 38% of the bugs can be prevented by types. So using types, IDEs can provide code editing features like code completion and parameter information. Because of this, your users might want to use types and primarily TypeScript. So why do you have to support types? Because TypeScript is the most popular type system in JavaScript. And there is an ECMAScript proposal for TypeScript annotations, but it will take time to get standardized and get supported across all JS runtimes. So how do you support types? So either write your code in TypeScript, okay, if you like TypeScript, or generate types from comments for your JavaScript code by running TSC. The types can be linked in the types field in the package.json if you want to publish your types in default variant, or if you want to submit your types to definitely type, then it can be published under types organization npm. So you might mention, isn't this going to make it difficult for your users to use TypeScript? Do they have to add types as a dev dependency? There are certain package managers like Yarn does it automatically, so you don't have to worry much about that. So what of types? It depends. Maybe I should copy this slide and just say title. So your users will most likely need TypeScript types, so you are most likely have to publish TypeScript types. So debugging. So let's see why of debugging. That is, if your package code is in a language which compiles to JavaScript, like if you wrote code in TypeScript, but you have to publish JavaScript code, right? Then you need to publish source code and source maps to help with debugging if somebody needs to go through your source code. So it helps users to debug through the readable code. It improves the understanding of your package because they see the code written in the language which you wrote in, and helps them unblock themselves if they are blocked, or they can create relevant bug features, bug reports or feature requests that would help you fix those bugs or work on that feature request. So how does it work? So you can generate the source map for your types, for your files in TypeScript config. So in TypeScript config, you have source map true or inline source map true that will generate source maps. And you can include TypeScript source by mentioning source root where the source exists, or you can just publish inline sources, which will just put source code below your transpiled code. So let's see what you need to do in debugging. So if your package code is in language, it compiles to JavaScript, do provide sources and source maps. And if it cuts into your installer publish size quota, release a debug variant using debug distag. Just like we talked about node distag, you can use debug distag. So let's talk about observability. What is observability? Observability is the ability to measure system's current state based on the data it generates, like logs, metrics, and traces. Observability helps developers build faster, stable applications. So back in mid-2010s, there were competing APIs like Open Tracing and Open Census. In 2019, luckily, they got merged into Open Telemetry. So let's see how Open Telemetry works. You can add out-of-the-box support for Open Telemetry or add an instrumentation in an external package. So this is how your users will write code. That is, it will import trace from Open Telemetry API. Sorry, not users. Your instrumentation code will be written like this. You import trace from Open Telemetry API, and then you create a tracer and you create a span, and you tell how long the span works. I should probably have put one screenshot here. So what do you need to support? So add external instrumentation for your package either in your NPM scope or in OTel. So that is my recommendation. You can add out-of-the-box instrumentation also, but that will increase the all publish install size, and you will have hard dependency on Open Telemetry if things change in future. So the external package can be named as your scope name, Open Telemetry instrumentation, if you are using a scope, or if you want to put the code in Open Telemetry GitHub, then you can create Open Telemetry like instrumentation package name. So conclusion. Wow, we have how much time? 3 minutes. So let's talk about what the opinionated conclusion I have provided in this talk. So browser support only modern browsers ES6+. Servers support node.js with optional Dino or Cloudflare workers support if your users need it. For JS native, it depends. Okay, ideally you have to support React Native. For module formats, dual package perform dual packaging of CJS plus ESM, and you can also provide a ESM only variant if your users need it, because some people just want to use ESM. So then for sizes, aim for smaller publish installer bundle sizes in general. And for types, at least publish TypeScript types, and optionally use TypeScript to write your module if you are happy with it. For debugging, provide sources and source maps in debug variant if you are not using JavaScript for writing your module. And for observability, write a Open Telemetry external instrumentation package. So I'll wait for 10 seconds for you to take this picture, because this is another photo which can be shared on social media. We have 2 minutes remaining. Yeah. Okay, so thank you for listening. My name is Trivikram Kamat. My Twitter handle is Trivikram, and GitHub is Trivikar. You can find me there. And this is where slides are. We have AMA channel on Discord, so you can ask questions on AMA Trivikram Kamat. Yeah. Thanks.